In the previous video, we have seen how to calculate moles, and now we're going to see how powerful this can be in figuring out the number of atoms or molecules present in a particular vessel. So we already know that 1 mole of anything is basically this much of it, of that thing, whatever that is. So if I tell you that you have 1 mole of sodium atoms, so that basically means you have this many sodium atoms. So likewise, if I tell you that you have 2 moles of sodium atoms, you have 2 times this, which is probably close to 12.044 times 10 to the power 23 sodium atoms. So if we know the moles of something, we can figure out how many of that particle is present. So this is a very powerful tool. So you can have a problem like this. Say they might want to know that how many sodium atoms are present in, say, 2 grams of sodium. So what you do is you need to find the moles first. So the way you do it is using the formula of mass by molar mass, we figure out the moles of sodium here. So moles of sodium is going to be the mass of sodium divided by the molar mass. I'm just going to write mm for molar mass. So you have 2 grams, and the molar mass of sodium is from the periodic table, 23 gram per moles. So your grams would cancel out. So you have 2 by 23 moles of sodium. So to find out, I know the moles right now. So I have the moles here, and I know that 1 mole is the Avogadro's number of particles. So with this number of moles, I can figure out the number of sodium atoms present. So what I'm gonna do is, for the number of sodium atoms is equals to gonna be moles times the Avogadro's number. So the moles here is 2 by 23 mole times the Avogadro's number. So think of it this way. So you have this many atoms in 1 mole. So for this guy, this is gonna be, let me check here. So, I mean, I'm not just gonna go in there, but you can use a calculator and figure this out. But it gets tricky when you have, I think relatively tricky. It gets relatively tricky when you have, say, a molecule such as CO2. So what's gonna happen is, if you have, say, 2 grams of CO2, so you need to find out number of atoms. This is very important. They're asking about the number of atoms and the number of molecules. So with the 2 gram CO2. This is 2 grams of CO2. So this is CO2 is a molecule. This guy is a molecule. So if you find the moles of that, you'll find the moles of the molecule CO2. You're not getting the atoms. So okay, let's figure that out first. So moles of CO2 is going to be the mass of CO2 divided by the molar mass of CO2, which is going to be 18 times 2 for the 2 oxygen. Oh no, it's going to be 16, sorry, excuse me. So this is going to be 16. So it's going to be 16 times 2 plus 12 for the carbon. This is grams per mole. So what you do is this is 0.045 moles of CO2. So once you know the moles of CO2, you can find the number of molecules of CO2. So molecules of CO2 is going to be the number of moles times the Avogadro's number. So the moles is 0.045 times the Avogadro's number. So that is going to be so this is going to be 2.74 times 10 to the power 22. And this is the number of molecules of CO2, because you have used the mass of the molecule. So the mole you figure out, that's the mole of the molecule. So the number of particles you figure out is going to be the number of molecules. But notice here they ask for atoms. So what we're going to do is we're going to go here. We know that in one CO2 molecule, what you have is 1 carbon, it's double bonded to 2 oxygen atoms. So you have 3 atoms in one molecule of CO2. Okay. The other way to think about it is that you have 1 carbon and you have 2 oxygens, and they make up my CO2. So basically, for one CO2 molecule, I have 2 atoms of oxygen, and then I have 1 atom of carbon. So in total, I need 3 atoms to make 1 molecule of CO2. So this is the number of molecules of CO2 up here. Here, this is the CO2 number of molecules of CO2 you have in 2 grams of CO2. So to find out the total number of atoms, we need to multiply this with 3. Because, okay, let me write it here again so that it becomes easier to understand. So we have 2.74 times 10 to the power 22 molecules of CO2, which is made up of 3 times 2.74 10 to the power 22 atoms, right? So this is going to be So this is going to be 8.21 times 10 to the power 22 atoms. So this is a very powerful tool, so we can use the Avogadro's number and moles to figure out actually how much or how many particles are present. So that's that. So in the next lessons, we're going to cover a little bit more complicated problems of mole calculation that you might need